Good morning, folks. I want to continue today on page 14. Page 14 talks about puttable bonds. So just as you have a callable bond, where the issuer has the right to call the bond at his will, in this case, we have puttable bonds where the purchaser, the bondholder, the purchaser, not the issuer, now has the option of when to redeem the bond. When we buy a puttable bond, we usually end up with a lower yield to compensate for the fact that we can be redeeming the bond whenever we feel like it. So it says here, when purchasing a puttable bond, one should expect a lower yield rate to compensate for the flexibility you have as to when you want to redeem the bond. When you are the purchaser of a callable bond, on the other hand, you should consider your yield rate to be the minimum possible yield rate of all the possible call options, because the issuer will exercise the call option which will result in the lowest yield rate for you. Obviously, he's interested in paying as little as possible, so he will choose the option that results in your lowest yield rate, and you should count on that, as we said last time. Next, we talk about floating rate bonds. A floating rate bond is a bond for which the interest rate, meaning the coupon rate, convertible M times a year, changes over the life of the bond. So alpha M over M now of T. That means this is a function now of time. This is your coupon rate, effective coupon rate. And this changes over the life of the bond. It could be a function of time. These types of bonds are common as the market changes daily. Let's do an example. It says, given a 6-year 1,000 par bond, so F equals 1,000, C equals 1,000, with annual coupon rates 0.05, 0.054, and so forth. So they're giving you each alpha 1, which is equal to R for that year. So R is no longer constant like it used to be. Find the annual yield rate if P is equal to F. So now price is also equal to 1,000. So I have all these different FRs now. What are those FRs? Let's list them. FR, in the beginning, it's 0.05 times 1,000. So let's say 1,000 times 0.05, because this is F, this is R, is equal to 50. The next one is 1,000 times 0.054, so that's 54. And the next one is 56. And the next one is 62. And 58. And 66. And I'm done. And the question says find the annual yield. So let's set up our price equation. Price is equal to all the different coupons discounted, meaning present value of all the different coupons. So let's write here, discount them to time 0 plus the present value of the redemption. Can't forget that redemption, meaning discount that redemption. So I'm nearly done. 1,000 is the price. They told us the price. So 1,000 equals 50. That's my first coupon. Discounted 1 year, 1 plus y. I'm looking for y. Plus 54 over 1 plus y squared. Plus 56 over 1 plus y cubed. And finish this up. Plus 62 over 1 plus y to the 4th. Plus 58 over 1 plus y to the 5th. Plus not only 66, but I also have a redemption here. So 1,066, which comes from 1,000 plus 66. Here's the C, the redemption, and here's the coupon. 1 plus y over 1 plus y to the 6th power. Stick this in your calculator, solve for y. Y turns out to be 0.0577. Hope this is clear. Let's move on to page 15. This example is from your text, page 287. Option A, you have a bond, a 10-year bond, annual coupons with face 5,000. And price is 4,800. Didn't say anything about the redemption, so let's assume something here. Assume this is a par bond. So that F is equal to C. So this is a fixed rate bond, fixed. And option B is a floating rate. It's a 10-year. F is equal to C, so par bond with semi-annual coupons. Price is 4,800, so price is lower than C, meaning discount bond. Floating rate bond with coupon rate in the kth year to be 0.04 plus C times K. Find C so that the annual rate of the two options are the same. Find C so the annual yield of the two options are the same. Okay, let us begin with option A. F is equal to 5,000. R is equal to alpha 1. And that's 0.05. Therefore, FR is equal to 5,000 times 0.05, which is 250. Price is equal to 4,800. Redemption is equal to 5,000. P is less than C. There's a discount situation. The only unknown here is the yield rate J. Let us find J. So let's use our basic price formula. P is equal to FR A angle NJ plus CVJ to the nth power. 4,800 equals 250 because my F and F times R is 250. So here's the coupon. So 250 A angle 10 J plus 5,000 redemption 1 plus J to the minus 10th power. So 4,800 equals 250 1 minus 1 plus J to the minus 10 over J plus 5,000 1 plus J to the minus 10 power. 1 minus V to the N over J. Okay, that looks good. Stick that in your calculator and solve for J. J equals 0.0553147. That's annual. Annual yield rate. Next, I work on option B. So let's go here. Option B. Now I have floating rates. So F is equal to 5,000. C is equal to 5,000. P is equal to 4,800. And let's see, floating rate bond with coupon rate in the kth year to be 0.04 plus CK. So that's in the tth year, it would be 0.04 plus CT. Let's write that. Alpha 2 of T is equal to 0.04 plus CT. Therefore, alpha 2 over 2 is equal to 0.04 plus CT divided by 2, which is equal to 0.02 plus C over 2T. So this one has 2 coupons each year, 2 coupons per year. So there are 20 coupons. Let's draw a timeline for this one.